An inverse function reverses the effect of a function. It is denoted by f to the power of negative 1x. So for example, f2 equals 5. Its inverse would be f to the power of negative 1, 5 is equal to 2. Only one-to-one functions have inverses. A function is an inverse if its graph passes the horizontal line test, meaning any horizontal line will intersect with the graph at most once. The domain of a function becomes the range of its inverse, and the range of a function becomes the domain of its inverse. The graph of the inverse is a reflection of the graph of the original function in the line y equals x. For example, to find the inverse of a function, first replace fx with y, then swap x and y, then solve to isolate y. Let's look at an example to better understand this. Find the inverse of fx is equal to 4x minus x squared, where the domain is x is equal to or less than 2. Now, first we'll swap fx with y. So now for this equation, it's in the general form. So before swapping x and y, we can write it in the vertex form, or we can simply solve it with the quadratic formula. Personally, I'm going to switch it to the vertex form first. So we'll have y is equal to negative x squared plus 4x. Y is equal to negative x minus 2 squared plus 4. So now we can swap x and y. So x is equal to negative y minus 2 squared plus 4. And then now we must isolate y. So x minus 4 is equal to negative y minus 2 squared. And then we'll square root both sides. Y minus 2 is equal to plus or minus root x minus 4. Now, since the domain is x is less than or equal to 2, so since x is less than or equal to 2 for fx, the original function, this means that y is in fact less than or equal to than 2 for the inverse. So y is less than or equal to 2, which means y is y minus 2, less than or equal to than 0. So it'll be negative. So it will be y minus 2 for the root negative 4 minus x, and y is equal to 2 minus root 4 minus x. And that is the inverse of the original function.
Please like and subscribe, please.